Right now you're looking at the LightWave Server console. This is the user interface that administrators and developers use to manage LightWave Server. When you first sign in, you see the dashboard view, which shows the current status of LightWave, its server and worker processes, the TCP/IP ports that have been configured and their available services, and finally the version and license information. So we're going to create a RESTful service that implements a CRUD API, that's create, read, update, and delete, for managing employees or employee resources. Our first step is to load the request and reply inter-process message definitions that our sample employee server uses into a LightWave dictionary. From the console menu, click Dictionaries. Here we see a list of existing dictionaries. I'm going to add a new dictionary by clicking the plus icon here. The dictionary name can be anything you want, whatever's meaningful to you. Let's enter employee defs as our dictionary name. Then we enter the location of a DDL dictionary that contains the definitions we need. Now just click the Create button, and there you see the definitions that have been imported. Let's look at the employee create request message definition to see what it looks like. We've got two different formats you can view. JSON, that's JavaScript object notation, and binary. Here you see that the create request consists of a request code and an employee data structure, which in turn consists of the employee's name and address. Now let's look at the employee create reply message definition. It simply includes a reply code and the employee number assigned by the server to the user that was created by the request. Now, keeping those two definitions in mind, let's hop over to the API editor. On the main menu, click APIs. Here you would see a list of APIs that have been defined. The list is empty since we haven't defined any yet. So let's create a new one by clicking the plus icon. We'll give this API a name. Let's call it Employee. And a description. Now we have to add an operation. An operation consists of a path and a method. An API can have multiple paths, and each path can have one or more methods associated with it. The path is part of the URI that we spoke of earlier. Click the plus icon to add a path. Here we'll enter employee. Remember, in RESTful interfaces we have resources, and in this case employee is a resource collection. Now let's add a method. A path does nothing by itself. Click the plus icon following the path. This opens the method detail view. We're defining a method to create a new employee. By convention, to add or create a new resource, we use the post method. We'll also add a short description. Because the sample employee server is running under pathway, we select server class send as the guardian IO type to be used by LightWave to send messages to the server. The sample server requires a TMF transaction to insert a record into its Nscribe database. So we'll select the begin or resume transaction option so that LightWave will automatically begin a transaction before sending a request to the server if we don't supply an existing active transaction ID, or resume the transaction if we do supply one. Now we need to specify the server name that the request message should be sent to. LightWave gives a lot of options about how to determine the server name parameters, but we'll use the simplest and most common method, entering a constant value, a string containing the name. For process name, we enter NWEMP, the name of the pathmon process in which our employee server is configured. For server class, we enter employee server. which is the server class name we configured in the NWEMP pathmon. Now let's move on to the request message. The first thing we need to do is specify the definition or type of the interprocess message that LightWave should send when an application calls this API. Click the Request Message Type field. This opens the message type selection dialog. First, we select the dictionary that contains the definition we want. In this case, it's the employee defs dictionary we created earlier. Now we select the definition or message type for employee create request and click OK. Now that we've specified the message type, we can specify how we want the fields in the request message to be filled. We do that by mapping. We want to set as part of this API's definition the request code that tells the server we're sending a create message. We want to set it here to hide this detail from client applications. To add a field mapping, click the plus icon. Enter request code for the field name. The source for this field setting is constant value, and the value we want to set is 1. Why 1? Because we know that's how the server, the employee server, identifies an employee create request, when the request code is equal to 1. Now let's add a second mapping. We want to set the employee data structure in the employee create request message from the contents of the HTTP request that the calling application supplies. Enter employee data for the field name. This time we select HTTP request element for the source and body for the element. Now let's configure the reply messages for this request. Now the employee server can return 2 different message types depending on whether the creation of the employee succeeds or fails. Let's handle the success case first. When the create operation succeeds, the server sets the first 2 bytes of its reply message to 0, so we enter that for reply code. In that case, the definition of the message will be employee create reply. When the server replies with success, we want to set the response HTTP status to 200 because that's the custom in HTTP. Also, when the server replies with success, we want LightWave to automatically commit the TMF transaction, so we select that here. We could also opt to keep the transaction alive by specifying suspend instead of commit. Then we could use the transaction in another operation. Notice that just as we could map fields in the request, we can also do so in the reply. In this case, we're going to copy the entire employee create reply to the HTTP response. The API editor has already added that for us. We have another feature that we skipped over earlier. That's the field hiding feature. We're going to use it now to hide the reply code field. While we've specified for the entire employee create reply to be copied to the response, we're now indicating that the reply code field in the message should be hidden, or that one part of the server reply should not be returned in the response to the client. There are various reasons you might want to do this. In this case, we want to hide that server detail from the client, since after all, it always will be 0 in the success case. So let's collapse the detail for the success case by clicking this up arrow icon. Now we can work on the case where the employee server returns some sort of error, so let's add another reply. For reply code, we could enter a single error, or a list or a range of codes that the server uses to indicate an error. However, it's often easier to use the wildcard value star to stand for all other codes that have not otherwise been specified. So in this case, that means all other codes other than 0. For message type, we know that employee server returns a particular message type when an error has occurred, and that type is employee request error. Now in this case we want to set the HTTP status to 500, which is customary for errors. And for transaction state, we want LightWave to automatically abort the TMF transaction when an error has occurred. We'll leave the default message field mapping, which copies the entire employee request error message to the HTTP response. That's it. We've defined the create operation. Let's click OK to close the method detail view, and now we see that the post method appears under the employee path. We click the Save button now to save the whole API. Alright, we've completed steps 1 and 2, which are the longest. The next step is to create an access control policy. LightWave provides 2 access control policies by default. The Allow Anonymous Access policy, which allows access to anyone, no user or password required, and the Allow Any Authenticated User policy, which allows access to any user as long as they supply a valid username and password. We can create additional policies by clicking the plus icon. We can give the policy a name. And a description. We can specify which user or group identities will be granted access under the policy. I'm going to restrict access to the admin user, but you would configure your own users or groups, or perhaps create an application user. You can also restrict access by source IP address. If you want to restrict access to certain parts of your network, you can enter an IP address or range. I'm going to skip that and keep the default rule, which is to not restrict by source IP address. Now we click Save to save the new policy. Okay, just one more step to go. Let's deploy the service. Select Services from the menu. Once again, we click the plus icon to create a new item. We enter a name and description. Now we pick the access control policy we want to apply to the service. If we wanted our service to be accessible only on a specific TCP/IP port, we could enter the port or a port range here, but we'll leave the default for now. Now we select the APIs that we want to include in this service. So we select the employee API we created earlier. Finally, we need to enable the service, and we click Save. We're done. We've created an API and deployed it as a service. Now to save you all the pain of watching me create the remaining CRUD operations, I've gone ahead and done that while you weren't looking. Here's what the complete API looks like. We've got 2 paths. Employee, which is a resource collection with 2 methods. Get, which returns a list of all employees, and Post, which creates a new employee. That's the one we walked through all the detailed steps on earlier. We have a second path, employee/employee ID, which identifies a specific employee resource. The name inside the curly braces is called a path parameter, and we can use the field mapping feature we saw earlier to map whatever employee ID is supplied by the client application into the server request message. For this path, we have 3 methods: get, delete, and put, all of which we talked about at the beginning of this presentation. Okay, now let's give them a try. If we click a method, it opens the method detail view. In the detail view, in the toolbar at the top, we have this little lightning bolt icon. Click it, and the API method tester opens. You can see an HTTP request template for the API that has been pre-formatted. All we have to do is enter some test data. and click Send. The request is sent to the server and the response is displayed. We can see that the response was successful and the employee number assigned to the employee is this value. Now we'll close this test and this API method and open the get method on the employee collection. Now let's test this one. There's no request message body associated with this request, so the text box is empty. We just need to press send. The response is returned and we can see that the employee we added a minute ago has been returned in the list. That's it. That completes the demo. Now all of this may have seemed a little complicated, but trust me, after you've worked your way through it once, it'll be easy from there on in. And there's always the documentation and our support team if you need help. The LightWave Server software, including this demo, is available for download from our website. You can install it and test the remaining CRUD APIs for yourself. Thanks for your time.